All right, here we are, our last big algebra topic before we get into the good stuff this year. We're going to look at radicals. So radicals, we're going to keep it simple with just square roots, an index of 2, no cubed roots or fourth roots or anything like that quite yet. And we're going to look at how to simplify, multiply, divide, and then rationalize. So let's get to it. Since all of these indices, since all of our radicals are going to have an index of 2, meaning we're taking the square root is the inverse of squaring. So it would make sense that we know all of our perfect squares. So hopefully you know all of your perfect squares, like 2 squared is 4, 3 squared is 9, and so on. If you don't have these memorized, I would write them down, memorize them. The more familiar these are, the easier simplifying radicals becomes. Because when you have to simplify a radical, all you have to do is figure out which of these is a factor of the number you're looking at, and you want to choose the largest perfect square as your factor. So let's jump on, I'm going to start with number 2. So 32. What we're going to do is start with 4 and work our way up and see which of these perfect square numbers is a factor of 32. So factor means divide evenly. Hopefully you have these, these like mental math facts. If you don't, you can always use your calculator. So we can do 32 divided by not 2, because 2 isn't a perfect square. 32 divided by 4 is 8. So 4 is the factor. But let's see if there's any other larger perfect squares that's a factor of 32 as well. So I'm just going to divide. 32 divided by 9, no, doesn't go in evenly. 32 divided by 16, look at that. 16 is bigger than 4. So I'm going to actually break this down into 16 times 2. Notice I'm using a perfect square factor, okay? The reason I'm doing that is because 16 is a perfect square, 4 times 4. These 4s get to partner up and escape from the radical. I like to think of the radical as like an escape room, right? The only way to escape the escape room is to find a partner in crime, and your partner has to be the exact same number. So these two 4s get to escape out of the radical. They join together as one, and any number left in the radical without a partner is stuck there. So the square root of 32 simplifies to 4 root 2, right? So again, you want to find that largest perfect square factor. So let's jump to number 3. So 27. So do we want to divide by 3? No, because 3 is not a perfect square. So we're going to look at our list and start with 4. Is 4 a factor of 27? No. Is 9? Sure is. 9 times 3. Again, I chose 9 because it's a perfect square. These 3s get to partner and escape. They escape out of the radical, but this 3 is left inside without a partner. So the square root of 27 is 3 root 3, okay? So let's go to number 1 now. So 256 is much larger, right? So we could start with 4 and work our way. So 256 divided by 4. All right, so 64. What about 256 divided by 9? Does that go in evenly? No. 256 divided by 16. Wait a second. 16 goes into 256 16 times. Do you guys see that partner there? So this one is a unique one. 16 times 16 is 256, meaning 256 is a perfect square, right? So we know that the square root of 256 is 16. Right? That we could actually add that all the way over here, 256, to our list. Okay? But let's say we didn't know that. Let's say we went to reduce and we started with the 4. Remember, it was 4 times, what was it again, 64? Oh, let me pull my calculator up here. It was 256 divided by 4 is 64. So if we were to write this down, 64, do you guys see that 4 and 64 are both perfect squares? So we could break 64 down into 8 times 8. We can break 4 down into 2 times 2. Do you guys see that these 2's found a partner and could escape the radical? These 8's found a partner. They can come out and escape the radical. And when they escape their room, they multiply outside together and they get 16. Notice that there are no other numbers in here that are all by themselves, right? They've all broken down into their partners. So we end up with the same answer, but it was way more work to get there than to just knowing your perfect squares. So as you're simplifying your radicals, make sure you have these perfect squares memorized and always find the largest perfect square factor to simplify with first. Okay? All right, so simplifying radicals is going to come up over and over. We're always going to have to simplify with all of our operations. So let's jump in and see what this is going to look like with multiplying and dividing. So again, you can feel free to pause to copy this down, but when you're multiplying radicals, we're going to multiply the outside numbers outside. We're going to multiply the inside numbers inside the radical, and then simplify. Same thing with dividing. We can divide the outside numbers. We can also divide the inside numbers. So notice we can keep our radicals separate in the numerator and the denominator, or sometimes it's easier to write these two numbers under the same radical and simplify that way. So depending on the problem, one form might be easier than the other. So let's take a look. Let's start with multiplication. So just like what I had said in that little box, we're going to take these outside numbers, the numbers that are outside of the radical. We're going to have 2 times 3, multiply them. Then we're going to take the numbers inside the radical, multiply them here, and then simplify. So 2 times 3 is 6, easy enough. We could multiply 3 times 6 and get 18 and then simplify that. You could also start thinking of your that partner, right? That whole aspect of, in order to simplify a radical, in order to escape the escape room, you have to find a partner. Isn't 6 3 times 2? If I break it down into its factors, do you guys see the partners in 3 and 3? So the 3's get to escape this radical and come on outside right away. And then 2 is left by itself. So our final answer is, let's see, 6 times 3 is 18 times the square root of 2. So you can simplify as you go. Let's say though, you're like, wait a second, what'd you just do, Mrs. Welch? Let me go back to this step here. Could you say 2 times 3 is 6, 6 times 3 is 18, and then just simplify 18? Sure could. This, would be 9 times 2. The 3, notice we would find that partner of 3 eventually and end up in the same place, right? So we would end up with the same answer, end up at the same place. We just took one tiny little extra step to get there, right? Because the 6 would come down, and then we'd have the radical 2. So we'd end up with the same answer of 18 root 2. It was just, were we going to multiply the 6 times 3 and get the 18 and then simplify? Or would we just start simplifying right away? It doesn't matter. Whatever makes most sense to you. All right. So this one, we'll start this. So let's see. Negative 2 times 5 is negative 10. The inside numbers, 8 times 5 is 40. Notice I did actually multiply these because 8 and 5 don't have any common factors, so I couldn't kind of do that shortcut. So instead I'm going to start reducing 40. The largest perfect square factor of 40 is 4, right? It's 4 times 10. I chose 4 because it's a perfect square. The 2's get to escape from the radical. The negative 10 follows down, so we're going to multiply these guys outside and get negative 20. And then who is left under the radical all by itself? The 10. So we're going to have negative 20 times the square root of 10 as our final answer. So here we have multiplying radicals. And again, you guys, if you need to pause or go back, feel free. So 2 examples with multiplying radicals. Now we're going to jump down and look at dividing radicals. So here we see a perfect example of deciding, are we going to keep the radicals separate, one in the numerator, one in the denominator, and then simplify them separately? Or is it easier to actually rewrite this as one fraction under the same radical? So I'm going to kind of show you both ways. For this first step, I'm going to show you let's try by putting the 125 and the 5 under the same radical. If we do that and we start simplifying, 125 divided by 5 is 25. This was a great step for us because 25 is a perfect square, so our answer is just 5, right? So this, it was easier for us, or it wasn't very difficult to combine the two into one. If you didn't see that, let's say you kept them separate. So I'm just going to move these guys over a second. Let's say you were dealing with this separately. So you said, first, I'm going to simplify my numerator. Square root of 5, we can't do anything with that. What if we try to think of the largest perfect square factor of 125? So you start dividing. Does 4 go into 125? Nope. Does 9? No. 16? No. Does 25, right? Notice all these numbers I'm dividing by are all the perfect squares. We said it's 25 times 5. So if we were to do it this way, then it would be 5 times 5. The 5s would escape, and this 5 would be left underneath. Do you guys see that this square root of 5 divided by the square root of 5 cancel? It equals 1, and then we'd get the same final answer of 5. So you'll see that sometimes you have a choice, right? We could keep them separate, one radical in the numerator, one radical in the denominator, simplify as much as we can that way. Or, again, I'm just going to kind of slide this over. Or do we want to rewrite this so that the two radicals become one and then just simplify what's inside? Now this one's a unique one. It happened to work both ways. Not every division problem does that. So you do have to look at it kind of analytically and see which one works best for you. So I'm going to leave both of these here so you guys can kind of, decide which one you like best, which one made more sense to you. All right. And last, reducing radical. This one with dividing, remember that the outside numbers can talk to each other, the inside numbers can talk to each other, but the outside cannot talk to the inside, right? So when we're looking at this one, can we just do 24 divided by 8 and just divide that way? No, because the 24 is under the radical. So we do need to take some steps to try to simplify and be really careful keeping track of what's inside and what's outside. So I'm going to first reduce the numerator. The largest perfect square factor of 24 is 4, 4 and 6. This is 2 and 2. So my numerator is, the outside numbers are 2. The inside number is 6, right? The 2's got to partner up and escape. The 6 was left underneath. And then our denominator is 8. That stayed. We can't simplify 8, right? So we were able to simplify the numerator. Now we have to see if we can simplify this fraction. Again, the outside numbers can talk, the inside numbers can talk. So the outside numbers in our case are the 2 and the 8. So if we were to simplify 2/8, that simplifies to 1/4. So our answer would be the square root of 6 all over 4. Now you can write it like that, or you can just get rid of that 1 and just leave your answer like this. You do want to keep going until your radical cannot be simplified any further. All right, so that is simplifying, multiplying, dividing, and the last thing is rationalizing. So in some cases, when we're dividing with radicals, if you have a radical left in your denominator, we have to rationalize that. So rationalizing is just a way of rewriting, getting the same numerical value, but the number just looks different. It doesn't have a radical in the denominator. And the way you do that is you multiply the numerator and the denominator by whatever radical is in the denominator. And then we simplify, of course, okay? So let's just look at number 1. I kind of started it. Why do we multiply by the radical that's in the denominator? Well, take a look. If we take square root of 6 and multiply by the square root of 6, the insides get to multiply to 36. 36 is a perfect square, so square root of 36 is just 6. Do you guys see that by forcing it, by making ourselves multiply by the exact same thing, these guys get to partner up? And when they partner up, they get to escape. right? So rationalizing, the whole process is done on purpose because by multiplying by the same thing in the denominator, we ensure that the radicals will disappear and this number gets to escape. Okay, so that's the whole point of rationalizing. That will happen each and every time. And then just like we saw, the outside numbers get to talk to each other. Let's see, 2/6 reduces to 1/3. So we have this equals 1/3 and then times the square root. Remember that 6 just stayed underneath. So our final answer, I know that looks kind of messy, is just the square root of 6 over 3 because we were able to reduce those coefficients, simplify that fraction. So that's what we're going to see happen when we rationalize. So we should expect that to happen each and every time, right? So when we look at this problem and we see that there's a radical in the denominator, we're on purpose. We're not going to multiply by any random radical. We're going to multiply by the same one that's in the denominator, right? So I'm going to multiply by the square root of 5 on the top and bottom. The top, nothing really like super interesting happens up there. 3 times 5 is 15. So that's fine. That's just like regular radical work. The interesting stuff happens down here. When these combine, when we multiply these guys, we end up with the square root of 5 times 5, which is the square root of 25. No surprise here that the 5's escape the radical. So the 5's come on out. And then this actually is our final answer. So rationalizing sounds fancy, but really it's just this nice streamlined process to get rid of that radical in the denominator. So here, this one's an interesting one. Could we jump in straight to rationalizing? Sure, but do you guys see that 2 and 12 have common factors? So maybe what we want to do first is simplify this. Let's put this all under the same radical, 2/12, which simplifies to 1/6. And then we can actually put them back into separate radicals, like so. The square root of 1 is 1. The square root of 6 is down below. So we just simplify this radical. We took a second to simplify the radical, or I'm sorry, the fraction. Now we're here. Now we can rationalize. We'll multiply by the square root of 6 over the square root of 6. We do this on purpose because, again, the numerator, nothing super fun, but the denominator, the square root of 6 times itself, is just going to give us 6. And then we're done. We can just leave it right here. All right, so we have radicals. Remember, you guys, if you have questions, rewatch the video. Try this on your own, and let me know tomorrow what questions you have. Oh, I see I skipped this one, number 4. I'll leave you guys to try that one on your own. We'll go over it tomorrow in class. Have a great day.